All right, let's do one more proof today. Given the measure of angle ABC equals 25 degrees, given the measure of angle BCD equals 5W degrees, given W equals 5, prove line X is parallel to line Z. Okay, so for my statements, I'm going to start with my givens, and I'm going to label my picture as I go. Okay, the measure of angle ABC equals 25 degrees. Measure of angle ABC equals 25 degrees. So that is given to me, and I'm going to look and see where it is. A, B, C. So that's this angle right here is 25 degrees. The measure of angle BCD is 5W degrees. The measure of angle BCD equals 5W degrees. So let's see where BCD is. B, C, D, that's this angle under here. Okay? All right, and then I know that the W is equal to 5. That was given to me also. Okay, and I can't really put that in my picture because that just is going to eventually go in for this W. In fact, we can do that now and then figure out how big this angle is, right? I can substitute that in right here. So I can say the measure of angle BCD equals 5 times W, which is 5 degrees. I just did substitution. Property of equality. So then when I simplify that and do that multiplication, the measure of angle BCD equals 25 degrees. All we did was simplify. Okay, so I can mark that up in my picture. Now I know that this angle is 25 degrees. I can see that these two angles are congruent, which if you're kind of thinking ahead means I probably do have parallel lines. But I have to identify the relationship between those two angles. So notice I have my transversal here, and then these two lines that I'm trying to prove parallel. So when I look at them, these two lines that I'm trying to prove parallel, what's the relationship between these two? They're inside the two lines, and they're on different sides of the transversal. So these two angles are alternate interior angles. I have to write that in my proof. I can't just assume that the person reading the proof will figure that out. So I have to write it down, okay? I have to write down that this angle, angle ABC, and the bottom angle, angle BCD, I have to show that they are alternate interior angles. That is given by the picture, okay, because it's displayed to me in the image that was given as part of the problem, okay? So now, the alternate interior angle theorem says if I have parallel lines, then these angles are congruent. But remember, I'm starting with if I have parallel lines. I don't know if I have parallel lines. That's what I'm trying to prove. So that means I need to use the converse that says if alternate interior angles are congruent. So I have to show that my alternate interior angles are congruent, which I've already written that they're both 25. I just have to actually write down that they're equal. So how do I do that, right? Well, I know the measure of angle ABC equals 25. Instead of writing 25, I'm going to write what else equals 25. I'm going to substitute this 25 for what the 25 equals. It equals the measure of angle BCD. I used substitution. So now, look what I've shown. I've shown I have alternate interior angles that are congruent. My converse says if alternate interior angles are congruent, then the lines are parallel. Now, sometimes it's tempting to look at the picture and go, okay, so my lines are Z and X are parallel. If I write Z as parallel to X, I'm not done because I want to use then I have to use my symmetric property to switch that around. So make sure you get them in the right order. X is parallel to Z. because if my alternate interior angles are congruent, then I have parallel lines. That's the converse. The alternate interior angles converse. Okay? So hopefully that gives you an idea of how you can use these theorems and converses in geometric proofs. All right? Thank you so much for watching.